Hello, guys, and welcome back to Plan QS with Ife. This is week one, and today we are diving into something that every serious QS professional needs to understand, and that's the transportation problem. By the end of this lesson, you will know exactly how to figure out the cheapest way to move materials from suppliers to your construction site. Let's get into it. So, we have the real life problem. So, let's start with a real life scenario. Imagine you're a QS on a project in Abuja and you need to supply cement to three different sites like Gariki, Meitama, and Lugbe. You've got two suppliers, one in Kubwa and one in Guagalata. But here's the thing, the transport cost from each supplier to each site is different. So the question is, who supplies what and at what cost? That's exactly what the transportation problem helps us solve. So let's try to get to know what a transportation problem is before we move into the calculation. Transportation problem is simply a method used to distribute goods from multiple suppliers to multiple destinations at the minimum possible cost. Three things are always involved. One, we have your suppliers, which is where your goods come from. We have your destinations, which is where your goods are needed, and your transport costs, which vary per route. This is a very simple concept, but a powerful tool. Now you might be thinking, why does this matter to me as a QS? Well, transportation is part of your project cost. Poor planning means wasted money. And on large projects, we are talking about millions of naira here. So your job is to plan deliveries smartly, choose the cheapest routes, support procurement decisions, and keep the project running efficiently. This is real QS work. To solve the problem, we need a transportation table. It looks like this. Rows are your suppliers, columns are your sites. The numbers inside are the cost per unit for each route. The right column shows how much each supplier can supply, and the bottom row shows how much each site demands. Once you can read this table, you're already halfway there. Now, before you can start solving, you need to check one thing. Is your problem balanced or unbalanced? A balanced problem is when total supply equals total demand. If that's the case, you're good to go. But if they don't match, say your total supply is 1050 bags, but demand is only 1000, that's an unbalanced problem and you cannot solve it yet. So you need to fix it first. How do we balance an unbalanced problem? Fixing it is actually straightforward. So let's start with step one. Step one is to identify the gap. So in our example, that's 50 bags of excess supply. And step two is to create a dummy destination. You can think of it as an imaginary site that absorbs the leftover supply. You assign it to a cost of zero because it's not real. Step three is to add it to your table, and now supply equals demand. So it is balanced and we are ready to solve rather. So we have three main methods to get an initial solution. First, we have the northwest corner rule. It is super simple. You can start from the top left cell, but it ignores costs completely. So it's only good for practice. Secondly, we have the least cost method. This is more practical because you can start with the cheapest route and work your way through. And thirdly, we have the Vogel's approximation method. This is the most advanced and the closest to the optimal solution. So in lesson one, we're focusing on the least cost method. So now let's walk through a full example. We have two suppliers, Bakalara with 400 bags, Kuba with 350, and Maraba with 250 bags. We have three sites as well. Gariki needs 300 bags, Meitama needs 450 bags, and Lugbe needs 250 bags. So the total supply equals the total demand, and that's 1000 bags each. So now the problem is balance, and we are ready to solve. So we're moving to step one. Step one, we scan the entire table and find the lowest cost cell. That's 100 naira from Maraba to Lugbe. So Maraba has 250 bags. Lugbe needs 250 bags, and that's a perfect match. what we do is we allocate all 250 bags to Lugbe. Now, Maraba is exhausted, it doesn't have any supply left, and Lugbe is fully satisfied, it doesn't have any demand. So we cross them both out and we move on. Step 2, we look at the remaining sales and find the next lowest cost, and that's 150 naira. And it's from Kubwa to Maitama. Kubwa has 350 bags. Maitama needs 450. So we allocate 350 bags, which exhausts Kubwa completely. But if you notice, Maitama still needs 100 more bags. We're not done with Maitama yet. So we move to the next lowest. And now, if you notice, you see that the only supplier left is Guagalada. Gariki still need 300 bags, and the route from Guagalada to Gariki costs 250. So Guagalada has 400 bags. Gariki needs 300. So we allocate the 300. Gariki is now fully satisfied. Its demand has been met. And Guagalada now has 100 bags left over. So we move to step 4. So now you're going to scan the table again. And scanning it, realize that Guagalada's remaining 100 bags can go to Maitama, which actually needs 100 bags. So the route costs 300, which is 300 naira to be precise. So we allocate 100 bags and that's it. All supply has been used, all demand has been met, and the table is complete. So here is our final allocation. Guakalada sent 300 bags to Gariki and 100 bags to Maitama. Kuba sent 300 bags to Maitama and Maraba sent all 250 bags to Lugbe. So this is clean, it is efficient, and all demand has been met, and every site is covered. Now let's calculate the total cost. So Guagalada to Gariki is 300 bags at 250 naira each, and that's 75,000 naira. Guagalada to Maitama is 100 bags at 300 naira, which is 30,000 naira. Kubwa to Maitama is 350 bags at 150 naira, which is 52,500 naira. Amaraba to Lugbe is 250 bags at 100 naira, which equals to 25,000 naira. So add it all up and you get a total minimum cost of 182,500 naira. And that's your answer. But wait, is 182,500 truly the best? That's a fair question. We have a feasible solution, but not necessarily the optimal one. So to confirm optimality, we used either the stepping stone method or the Modi method. Both of these test whether swapping allocations could reduce the cost further. Don't worry, we'll cover both in the next lesson. So before you move on, I want you to hit pause right now and test yourself. Can you answer these 5 questions? 1. What is transportation problem? 2. What method did we use? 3. Which route had the lowest cost? 4. What was the total minimum cost? 5. And when do you need a dummy? Write your answers down first, then check back. That's how you actually learn this stuff. And that's a wrap. Today we've covered what the transportation problem is, how to build and read a transportation table, the difference between balanced and unbalanced problems, the full list cost method step by step, and we've got our total cost of 182,500 naira. In our next lesson, we are going into Vogel's approximation method, which takes things up a notch. If this helped you, please make sure to like, subscribe, and share. It really does help the channel grow. See you in the next lesson. Bye.